So hello, and once again, um, welcome to Saturday morning coding. We are gonna continue coding this game, and well, hopefully you will learn something. And as usual, you can ask anything in the chat that you want to, and I will try to answer to the best of my knowledge. So yeah, let's do a recap. So this is what we had. We have now an imperfect puddle, and if we don't hit the ball goes away. So this is what we have so far. The player in the right will be the player, and the player on the left will be the computer that we will need to code. But yeah, there's a couple problems that we need to fix. There is this problem that let me see if I can show it to you. Yeah, that the ball can rebound from back as well. So in order to fix this, what I'm gonna do is we have our player paddle here, and is the ball who is colliding. So if this collides with and not this is colliding, and we also have to say that I think that essentially we don't need this, and this dot try how do we ball dot this dot x is bigger or equal than engine dot sprites dot player paddle dot x. Sorry, less or equal. That means that is to the left. So let's see, now it shouldn't have, after this modification, it shouldn't rebound from the back. So now we can reload even. Okay, this difficult test case. Yeah, it's still rebounding. So the X is on the top left corner. So we need to check that the X plus the width is smaller. This why it still rebounds. yeah, in the yeah, this is here what we are doing is that it's rebounding to the top and the bottom, and it's rebounding to the other player. But here we need to think this x this get width. Yeah, I'm thinking how can we do this in a sensible way. Maybe instead of colliding fully, maybe we can just check the left of the ball with the left side of the ball with the right side of the paddle. So we need a ball dot. This is not a it's a special case, so we cannot use the collision of the engine, because in this case it doesn't work if this does the paddle collision. And here we are gonna specify the paddle. Because we will need to use this as well with the other paddle, but so far it is paddle collision, then direction dot x, it's multiplied times -1. And so in this way we compare if we need to check that this dot the ball dot x plus this dot get width is bigger or equals than paddle, and I'm gonna tell that this is a paddle, and this is a STUMGE split, so so by doing this, the IDE knows that this parameter is a engine sprite, so we can get access to the function. So paddle dot x, and it's not enough, because if we do it now, like if we do this, it will mean that it will rebound all the time when it reaches the side of the this dot engine dot sprites dot, how was this, engine sprites player paddle. If There's a problem here, Bob. Damn. The paddle collision, paddle rebound. Let's see. I'm not understanding why this function is not called. So this is a very primitive but still okay-ish way to check if something is being executed. So yeah, it's yeah, cannot read property sprites of undefined. That's probably a problem with an engine. Yeah. So player paddle update function engine. So we need to pass the engine to this, and then the states of the ball once per frame. And here we pass the engine. We are extending, as you can see, we are extending the STUMGE sprite object, which provides the basic sprite functionality with our own extensions. So we are adding functionality to this object. So now we need to pass the engine. So this rebound needs to get the engine. Yeah, and because we check the collisions with this paddle, probably we will need to check the collisions with the other paddle, but that's when we are programming the computer play. Yes. Now, as we can see, it rebounds all the time with the with a hypothetical wall on the paddle side, but obviously we only want it to rebound when touches the paddle and not all the time. But this way we are gonna avoid that it rebounds from behind as it was happening. And I'm sorry that I could be looking at this for like hours. So let's continue. So now obviously we only want it to rebound when this is bigger, but also when the y is between the y of the paddle. So the paddle has boundaries. So the paddle now, the y is between this point and this point, and we want only the ball to rebound there. So now we are gonna do that. So and and this dot y is bigger or equal than paddle dot y, and this dot y is smaller or equal than paddle dot y, paddle dot y plus paddle dot get height. So this we are checking the boundaries. This is not exactly how the collision works, so so we had to override it. This is not exactly how the collision works in the engine, so that's why we had to override it. In the engine, it just checks that the boundaries overlap. So it's a box surrounding the sprite, and if it overlaps, then there's a collision. This only collides with the left boundary of the paddle sprite. unless I'm mistaken, which can easily be. Now it didn't rebound. Now it still rebounds from the back. Yeah. The thing, it was parallel.x. We cannot do the bigger than, because otherwise we are taking the whole region. So if it's, so this is the left, the right boundary of the ball and the left boundary of the paddle. Yeah. Yeah, but now we have the problem that if it doesn't collide exactly, how can we fix this? The thing is, this bypass. So the y's are correct, but the x is not correct, because obviously it can happen that that it doesn't fall right in that pixel. We can just have a threshold of few pixels. It should have a threshold, so it should be paddle.x ball dot collision threshold, and let's say 3 pixels, and see if this works. Is bigger or equal than paddle.x, and smaller or equal than paddle.x dot this dot collision threshold. We have created a small sub box which is a few pixels on the left side of the paddle. And now it doesn't rebound from the back, only from the front, which is exactly what we needed, or what we wanted. Yeah. And here you can see that this function, the collision function, is called once per frame, so it's about 60 times per second. Okay. So we are, I'm gonna extend the explanation of this. So it's so it is, we have created, let's say, a smaller sub box for the collision with the sprite. Never parallel sprite, sub hitbox, I think they call it. But yeah, this is an update on. I mean, this is our own custom collision. That's the reason that we couldn't use the regular collision. So okay, so now we have paddle that collides with the ball. And it seems that now it's colliding. Yeah, it doesn't collide from the back, which is what we wanted to avoid. Yeah, damn, it still collided from the back there. That's the problem. Yeah, it still collides from the back. I'm not sure how can we do this. It still collided with the back. We might need to have a time restriction because this is not working as we expected. Yeah, I mean, it still should only collide with this sub box, but maybe we can say that it collides only once. Only once in 10 frames or something like that. I think 10 frames should be more than enough that it goes out. So yeah, so let's see. Ball, last collision. Last collision equals -1. We only take if this is outside of this. The engine has the number of frames, so we can say this dot last collision if this dot last collision minus engine dot frame count. Oops. The engine dot frame count is bigger than collision threshold and collision. I'm gonna name this collision frame threshold to 10 frames, even 1/3 of a second, 20 frames, and collision threshold. I'm gonna rename this to collision pixel threshold. So if this the last collision minus engine frame count is bigger than no, it should be the other way around. If the engine frame count minus this dot last collision is bigger than this dot collision I don't know where. Anyway, collision refactor rename. Yes, collision pixel threshold. Oh, do refactor, yes. Do refactor. This doesn't work very well with, unfortunately, this with JavaScript for some reason. Yeah, anyway. So the frame game and this dot last collision is bigger than this dot frame collision frame threshold. Then we change direction and we set this dot last collision equals to this dot, dot engine dot frame count. Done. I'm trying my best to recreate the problem, but it's difficult. Even though it's still not perfect on these corner sides, I think it's good enough. So yeah, it doesn't collide from behind. Now we saw it. Okay. Yeah. So I think that problem is solved. So now now I want to create two things. First of all, the a boundary on the top and on the bottom. So instead of checking yeah, instead of checking that it's bigger than 0, what I want to do is that I have walls. So I have on the upper part, so around here I have balls. I mean balls, walls. So I can use a little bit here to set the score and something message, and same down here. So it feels like it's a little bit more of a game and not just a random random thing. Plus, we need anyway some sort of user interface that tells at least the score, and but we will see in the future. But now I'm gonna create a bar, a black bar that uses the whole screen. So so we get boundaries and we get a little bit of space on the top, and then we have to change the collisions. So so I'm gonna create a new sprite, a new file called wall.js, and I'm gonna include it here. and the wall it's gonna be wall graphics. It's gonna be, I don't need the editor for this, so I'm checking how to do how to create an array that is without having to, because it's gonna be all the same color. So wall graphics. So the size is wall graphics is so we have so it's like a new array of 10 pixels. I mean 10 height, and then for STUMGE width less than 3, let's say 10 pixels for example. Then wall graphics of wall graphics, the E is new array. Then dot feed, how do we do this? Array field JavaScript. Dot field with the color 3, for example. So now we have that wall top wall equals a new STUMGE sprite. Wall graphics. We can put it in 0, and the Y can be 20, for example. And bottom wall and new STUMGE sprite 0 STUMGE height minus minus 10. Yeah, we need to extract this to another, and then so player paddle, and then we need to do we need to set engine sprites top wall almost top wall and bottom wall equals bottom wall. Yeah, those we only need to set. We don't need to update. So this dot set sprite engine dot sprite dot top wall bottom wall. So now we have walls, hopefully. Length of undefined. So what is undefined here? What? Top wall, bottom wall. Length of undefined. So yeah, now we are building the walls, but they are not showing. They are not showing, and I wonder why. Are we painting them? Yes, we are. But they are the same color as the background. Damn. They are color 3, so let's try to change it to 1. And obviously they are not good. They are mirrored. So we did this the other way around. And then here STUMGE width. And let's see now. Now we have wall. We have walls. And I think that they should be definitely color number 2 in the palette. So let's see. Color number 0. That's total black. So yeah, now the player paddle should be, the initial position can be in the 150 So this should be STUMGE width minus 20, for example, and STUMGE height divided by 2. This doesn't matter because actually it's not gonna be. Yeah, this is just approximately in the middle. Minus 5 minus 10 maybe. Yeah, and then the other one should be, the other paddle should be in the same, STUMGE height minus divided by 2. But this is 10. This left paddle will be moved towards the to a new class. So when we are done with things, so yeah, I think that this is too far down. So that's the first thing that we need to correct. Wall graphics. Maybe 10 is enough. So we can have the score here. This. Oh yeah, the thing is that we are, this distance is the same as this, because the starting point of the sprites is on the top left corner. So so yeah, in order to make this STUMGE width minus STUMGE sprite player paddle. So it should be it's minus now they should be the same. Yeah, now they are the same distance from the. Yeah, now this can still move freely, which is not what we want. So the paddle, instead of the player paddle, instead of colliding with the top, so if this dot if this dot collides with engine dot sprites dot top wall, this is the name, top wall, then this dot y equals engine sprites dot top wall dot y plus engine dot sprites dot top wall get height. So now we are colliding properly with the top wall, still not with the bottom wall, but with the top wall. Let's do the same now with the bottom wall. Only we can only collide with the bottom wall when we are going down. So this dot y equals the engine sprites dot engine sprites dot sprites dot bottom wall dot y minus minus this dot get height. Yes. It's not top wall, it's bottom wall now. So now we have proper collision with the top and bottom wall for the plier paddle. Now we need to do the same with the ball. Now we need to do the same with the ball. So this is collision with the paddle. This still works the same, but if this real y is less than or equal, if this real y is bigger than this is collision with bottom wall, this is collision with top wall. So if this dot collides with engine dot sprites dot top wall, and the direction changes, and if this collides with bottom wall, then the direction also changes. This will be removed when scoring is implemented. So this will be removed when the scoring is implemented, because this is the condition for when the ball goes through the other player's goal. So So we are here. We are. The collisions with the walls are very good, and those allow us to simplify this, at least for now. Which is always good to collisions with walls. It's always good to try to be synthetic and not have a lot of redundant stuff. So and it's gone, but yeah, this is starting to look a little bit like what I had in mind when I was thinking of the Pong clone that I wanted to do, and I think it's useful as well as a tutorial for STUMGE, for the game engine. I think it's really simple. I think it's really simple, and fun, at least from my point of view, to do this type of thing. So I hope that somebody jumps on the boat and starts creating with this engine. Yeah. Yeah, I'm thinking that what are gonna be the next steps. Yeah, I think that the next thing that we should do is to increase the, to improve the, well, to basically start with the machine computer player, and yeah, and once this moves by itself, we can actually start playing and we can start creating the scoring system. And yeah, one last thing that I think it needs to be done is the following. I'm gonna just very quickly add the how just for the looks. It's not gonna count anything yet, but I think that for the engine, we can just we can add two variables here to the engine. So it's engine dot player score equals 0, engine dot computer score equals 0, and yeah, and then just print it somewhere. I would like it to be centered on top. So it's so it looks like a real scoreboard on this line. So but so far I just want to show how easy it is to write text. So in the we can say engine dot write score. It is a function of nothing, and then we call it here this dot write score, and then we do this dot we can say let score string equals engine dot player score, no, not engine, this dot player score plus this dot computer score. But I think it should be the other way around, because our player is on the left side. So, and then we just do this dot put text, and this receives the text as a string and the position. So we can say STUMGE height divided by 2 minus 20, for example, and 2 pixels from the top, and then the score string is the one that we want to print. So this is how you write text. Oh, we are facing a problem that the this character is not on the charset. So let's see if this is implemented. The charset is very limited as it was in the Game Boy. So yeah, and then we can do minus 10, for example. This looks kind of okay, but obviously there's ways to center this, and we will do so. So now we have scores, and I think that this is enough for this session. We have progressed quite a lot with the collisions, and now the thing is starting to look like a game. And yeah, this is going forward, I guess. So yeah, thanks for passing by, and see you next week.